A ball of mass 0.45 kilograms falls from a building of a height of 21 meters. So what we have here is the ball falling, and then it's going to hit the ground right at this point. What is the ball's speed right before it hits the ground? A common misconception on this is we're looking for the speed when it hits the ground. It's 0 meters per second after it hits the ground, but we want to know right before it gets to the bottom. So we're going to use conservation of energy. At the top, at this position here, it's not moving, so all of its energy is gravitational potential energy. At the bottom, right before it hits the ground, the gravitational potential energy is essentially 0, so we're just going to use kinetic energy. So we have mgh is 1/2 mv squared. The first interesting thing you know, and this is something that Galileo said and it was proved on the moon, that all objects fall at the same rate regardless of mass, and you can see how the masses cancel out right here. We then solve for velocity, and you should be able to go to this step from here in your head. You can see the 2 coming over here. You then take the square root of v squared, and you're left with v is the square root of 2g times the height. You substitute in the numbers, and you come up with an answer 20.3 meters per second. Now, why did we change that to 20? Well, let's look up here. 2 sig figs here, you have 2 digits after the decimal. 2 sig figs here, so your answer can only have 2 significant figures. This is 3. Whenever a 0 is between integers like that, it counts as a significant figure. So we have to round it to the nearest 2 significant figure number, and that gives us 20 meters per second. So that would be B.